So in this video, I'm going to explain what supermesh analysis is, how we can use it, and we're going to go through this example where we find the currents flowing through each of these resistors at the top using supermesh analysis. Now, supermesh analysis is like basically mesh analysis, but it's what we have to do if we have a current source that's between two meshes or two loops. For example, if this was anything but a current source, like what you would do is you would just apply KVL around this loop, and then you would also just apply KVL around this loop. Those would be your two equations. You'd be able to find your two mesh currents. We can actually label those on right now. So let's label them on. So we're going to have I1, and we're also going to have I2. These are the mesh currents, but we're not able to use Ohm's law to figure out what the voltage drop is across an independent current source. So this is going to cause some problems with regular analysis, and when you have this type of situation, this is where we do supermesh. If you do want, you can label on the assumed direction of these currents. Let's say it's like that, and let's just assume this direction for IB. We don't really know, but we can just pick a direction. But when you do that, it's basically going to assume the polarities, which we're going to need later when we actually do apply KVL. But we'll get to that in a second. What we can get from this diagram, first of all, is we can at least figure out the relationship between I1 and I2. Because I1 is like going around the loop this way, and when you come through this area, I1 is going like this, and I2 is doing the opposite. I2 is going up like that. Now we know that there's 1.5 amps going down. So I1 minus I2 is going to be the net, which is 1.5 amps. So we can write that down. I1 minus I2 is equal to 1.5 amps. And we can just rearrange this if we want. So we have I1 is equal to 1.5 plus I2, just to get it in terms of one of the variables. So this is our first equation, and we need two equations because we have two unknowns. The two unknowns are our mesh currents, I1 and I2. And to get that, we're going to redraw the circuit, but we're going to remove the current source that's between the two loops. And then we're going to take KVL around this one giant thing, and this is what we call our supermesh. So like the first loop on the left is mesh 1. The loop on the right, we call that mesh 2. And this whole thing, when we remove the branch in between, we call this the supermesh. And we can apply KVL around it, and we're just going to take the current that's flowing through here as each of these currents. And IA is equal to I1 because on the original diagram, I1 is just coming through in the exact same direction with no other loops connecting it. So IA is equal to I1. And we've got the same thing here. IB is equal to I2. So let's maybe start in this corner right here, and we'll go around. So when we come into the negative terminal of the battery, we're going to assign that at the negative value in our summation for KVL. Maybe let's actually write that, KVL, for the supermesh. So we start off with a negative 2. Then when we come into the next resistor, we have to use a positive for the summation, and remember that V equals IR for Ohm's law. So the voltage difference from one side of this resistor to the other is the resistance times the current. So that is going to be plus for IA, or we can also say for I1. Then when we come into the next resistor, we're also going into the positive terminal, so this will be a positive in our summation. So we're going to have plus the resistance times the current, so this one is going to be 2IB or 2I2, same thing. And then when we come around, we're entering into the positive terminal of this battery, so it's going to be a plus, and it's just 3 volts. Plus 3, and that all sums up to 0, because when we come out the other side, we're back into the same node, basically electrically common to where we started. Alright, now we can just simplify this a little bit. So we've got minus 2 plus 4I1, and we have I1 right up here. So it's 1.5 plus I2 plus 2I2 plus 3 is all equal to 0. Alright, we can simplify that a little bit more. So we have negative 2 plus 6 plus 4I2 plus 2I2 plus 3 is equal to 0. So we've got 6I2 plus 7 is equal to 0. I2 is equal to negative 7 over 6, and that also means that just I2 is equal to negative 1.167 if you prefer decimal places, and that is amps. Okay, so we can take this value for I2, and we can just plug it right in here where we have I2 in this expression. So we have I1 is just equal to 1.5 plus negative 1.167. or in other words, I1 is just equal to 0.333 amps. So if the problem asked you to find the mesh currents, that would be the answer. We have I1 and I2. But if the problem asked you to find the branch currents, it would be asking for the green values here. And we pretty much have the answers already, but we'll just double check to make sure. So IA is equal to I1. So I1 is equal to 0.33 amps. So it is going positive in this direction. We can label it on as being equal to 0.333 amps going to the right. Now for IB, we calculated I2 to be negative 1.167 amps, and IB is equal to I2, so IB is equal to negative 1.167 amps, and that basically just means we have to switch the direction, and ultimately IB is really going to be going this way to the left with a value of 0.167 amps. So you can either write it going to the right with a negative current, but that's kind of confusing, so I would recommend just switching the direction if you're drawing it on the diagram, or just writing it down below with an arrow. You know, like we're just saying that IA is equal to 0.333 amps to the right, and IB is equal to 0.167 amps to the left. So yeah, that's how you do supermesh analysis. Anytime you see a current source between two meshes or two loops and you're asked to use mesh analysis, or you want to use mesh analysis, just know that it will become a supermesh problem. You're basically going to have to use this to find the relationship between the mesh currents on each side, and then you're going to have to remove it and then basically treat the whole thing as one big giant mesh, and then you're going to have the same number of unknowns as you have equations, and you'll be able to solve for the mesh currents and ultimately the branch currents. Alright, I'll see you in the next video, and we'll go through one more example on supermesh analysis.